All right, let's get started. Are there any questions on the material so far? Raise your hands if any questions. Yes, Vegas. Say that again? Oh, okay. So the question had to do with this technique of friendship nomination, which is a really cool kind of thing that we're exploring. And what I'll actually do is I'll discuss that next lecture in detail, and I'll give you some examples of some field trials we're doing in Honduras. And we just also finished something in Uganda, and we may be doing something in India, which take advantage of some of these network effects to kind of make the world better in a variety of ways. So it's a good question. I'll come back to that next time. Okay, so last time we discussed the difference between networks and groups. We saw evidence for spreading processes in networks of diverse sorts of phenomena using both observational and experimental methods. And we examined some of the possible explanations for correlations in attributes across connected individuals, including the notion of induction or a causal effect, homophily or love of like or birds of a feather flock together, or context or confounding as an explanation for why connected individuals might evince similar attributes of diverse sorts. Today we're going to be shifting and talking about some further topics, and one of the issues that often comes up when we discuss networks nowadays is prompted, of course, by the incredible prevalence of online networks, a technology that didn't even exist 10 or 20 years ago. And so people are wondering, does the online world resemble the offline world? And if not, how is it different? And in what ways is it different? And in what ways is it similar? And in fact, does the online world resemble the offline world in ways that we might exploit? What does the internet offer? How does it extend or exploit our ancient proclivities to form networks and be influenced by them? Now, certain things are indeed different about the online world compared to the offline world. And as discussed in Connected, we have at least four kinds of attributes, ways in which online interactions and online networks are different than offline ones. These are known as enormity, communality, specificity, and virtuality. So enormity, of course, means that the scale of interaction with these modern telecommunications technology is very different than the scale that was possible when we were hunter-gatherers, in the African savannah. Communality is a way in which these online interactions facilitate kind of pro-social behaviors. So it's possible to have Wikipedia emerge facilitated by this kind of technology, which wasn't as easy to do. We were always communal creatures. We always created a commons. We always collaborated in ways that I'll again come back to in a couple of lectures. But there's a way in which a communality is facilitated by online interactions. There's specificity. I mean, it just blows my mind when I think about what I take for granted. When I was a student, if you wanted to find an article in the library, it was a challenge. I mean, you had to, first of all, identify what you wanted by some other means. You had to physically go to the library. You had to, go up to the... Raise your hands if you've been up in the Widener stacks. Good for you. Isn't that an incredible smell, the Widener stacks? And I used to love studying in the Widener stacks when I was a student. I found this little special cubicle and, yeah, I know. And it was awesome. I just absolutely loved it. But, it was a pain in the ass to go and get stuff. I mean, it wasn't as easy as it is now. But more to the point, if I wanted you guys right now to find, a Norwegian military veterinarian, you can probably, with a few clicks of a mouse, find such a person. Imagine how hard it was prior to the emergence of the internet to be able to identify with that level of specificity sort of abstruse individuals or pieces of information. And finally, there's this notion of virtuality. And virtuality is that we are able to adopt certain identities online, which we were always able to do, but which are much easier facilitated by this technology. And so we argue in Connected that online networks are the same but different. They are the same insofar as they foster and privilege connection and influence. The desire that human beings have to be connected to each other and the desire of individuals to influence each other and their susceptibility to influence are the same online as offline. But there are certain features of the online world which are different. So for example, they're different in a variety of ways. here are some fascinating photographs by a man by the name of Robbie Cooper, and these are real people and their offline and their online avatars. So Robbie tracked down about 50 people and their avatars. So here's this gentleman and his avatar. And now it was always the case that people could pass as the opposite gender, right? I mean, there are famous historical examples of men passing as women and women passing as men, but it's much easier to do that in the online world than it is in the offline world. Virtuality. Or here's another very poignant example for me. The disabled can pass as the able-bodied. And this image brought tears to my eyes the first time I saw it. This is a little boy, obviously severely handicapped, probably from birth. I don't know actually his clinical circumstances. And this is his avatar. And imagine if you were such a boy, what kind of avatar would you pick for yourself, right? This man of steel, right? Impervious to the world, unwounded, multi-capable, a completely different kind of existence online than offline. So again, much easier to accomplish this type of transition online than off. So let's take an issue now, having looked at virtuality, let's take a little issue at the look at the scale, the question of enormity of online versus offline interactions. This is a natural social network of 105 close friends at a diverse Northeastern university, shall remain nameless, and on average, each of these students, every dot is a student, every line represents a friendship. On average, each student has 6.6 real friends, okay? These are like the human beings who are actually their friends as measured by some other way. And this is what happens when you add whether or not the two individuals, so the white lines represent real friendships, the green lines represent the two individuals are members of the same club, and the blue lines represent if they're also roommates. Now, sometimes there's a concerning circumstance in which a blue line connects two individuals and they're roommates, but they're not friends. I'm sure that's not the case for any of you in the room today. But you can imagine different kinds of connections between individuals, and they might and might not overlap. This is known as multiplexity, and it's discussed in the book, when you can have different kinds of interactions. And here's what happens when you add Facebook friends. On average, each person has 110 Facebook friends in this data set. By now, that number is much higher, especially in this population, when we did this project. 110 Facebook friends, even though they have only 6.6 real friends. And here's what happens when you expand to the whole college class. You get this incredibly complex set of online interactions, 1,700 students in this class. And the profusion of data can be overwhelming. And so for both analytical and conceptual reasons, we need a way to discern which of these ties in all of this mess are real old-fashioned friendships. So Facebook friends, and in fact other online ties, can actually be very tenuous connections. Do they influence us in the same way as real face-to-face connections is the question. Are we affected as much by our online interactions as we are by our offline interactions? So to discern friends in this data set, we proposed and implemented a method that we called the picture friends method, which was a method in which we required we only identify two people as friends if they co-appeared in a photograph on one of their Facebook pages where both of them were tagged. So for me to be your friend, even if you're my Facebook friend, there are no photographs of you and me, to my knowledge, at least on my Facebook page, where we both are on the page and we're both tagged. So for that to happen, we had to be in the same physical place. We had to get you to photograph the two of us, and then one of us had to go home and upload the image and tag it. That's a different kind of relationship than any old Facebook friend. And so we identified real friends using the picture friends method. And then we wanted to look at a variety of kinds of phenomena that might spread within this system. And one of the things we became interested in is movies. So this is the top 10 movies of this diverse Northeastern university, their favorite movies. And it turns out that if one of your Facebook friends, any old one of your Facebook friends, expressed an interest in one of these movies, and we came back and looked at you at a later point in time and saw whether you had adopted this interest, the answer was no. You were unaffected by whether any old Facebook friends expressed an interest in one of these movies. However, if one of your real friends expressed an interest in one of these movies, or also in music and in books, which we also looked at, then you did acquire that taste in those movies, but only for these three movies, Good Will Hunting, Pulp Fiction, and Love Actually. So we were able to begin to look at ways in which, if your friend expressed an interest in a movie, how did that influence you, how did that affect the probability that you would subsequently evince the same kind of an interest? And we were able to map these networks as well, and here we make the dots yellow if you're a Love Actually fan, red if you're a Pulp Fiction fan, and orange if you're a fan of both. Now, there are very few fans of both. They're just those little, in the top 10, those two little orange dots there. Interestingly, structurally, and this is very interesting to me, the Pulp Fiction fans are in this sort of cluster here, and the Love Actually fans here, and structurally the fans of both are located in between the two other clusters, which is very interesting. Now, what this says, however, is marketers and policymakers, public health experts, in fact, we ourselves, in some work that I'll show you next time, where we're trying to change people's behavior, not with respect to movies, but with respect to their adoption of like anti-malarial bed nets, or clean water interventions, or maternal and child health interventions in India, all these kinds of things that we're trying to do. We want to identify influential individuals so that if we can target them and they adopt something, we'll have these ripple effects, we'll have bigger ripple effects. But of course, marketers want to do the same thing. And so let's say, for example, you were trying to sell Love Actually, and you said, well, maybe let me find the central individuals in the network, that topological location, that structural location of those individuals. If I target them with what I'm selling, namely Love Actually, maybe I'll be able to get the whole group to like Love Actually. But of course, the problem in this case is that the central individuals are Pulp Fiction fans. So they're not going to be so interested in what you have to sell. So it's not enough to know about the structure of the network. You must also, as was always the case, know something about the index individuals. Now, this point about the difference between the importance or salience of real-life connections, face-to-face, offline connections, as compared to online connections, was really driven home to me and my colleague James Fowler, who's the co-author of the book and my best friend and long-term colleague. The way James and I was driven home, this point was driven home to us recently, because a couple of years ago, this woman by the name of Alyssa Milano, raise your hands if you know who she is. It's very gendered, I think. But anyway, I did not know who Alyssa Milano was, but Ms. Milano is a very hardworking actress, and at that time she had 1,050,000 Twitter followers. And very unexpectedly one day, she sent a tweet about our book, Connected: The Surprising Power of Our Social Networks and How They Shape Our Lives. This was, I think, 2 years ago, September of something 2 years ago. And there, right there, is the link to the Amazon.com website for our book. And on that particular day, that tweet of hers was retweeted by approximately another 1 million people. So 2 million people got a tweet to our book with a link that if you hit on the link, it took you straight to the Amazon.com website for our book. Now, James and I, because we're neurotic, we follow the sales rank of our book. And on the y-axis is the Amazon.com sales rank of our book. So up here is more sales, and down here is less sales. And this is the time period during which Milano tweeted our book, and there's when she sent the tweet. In fact, some people have looked at these data and said that when Milano sent the tweet, people rushed to the bookstores to return our book to the bookstores. Because, in fact, we estimate we did not sell, if anything, sales declined, we did not sell a single extra copy of the book, despite 2 million individuals receiving a tweet with the Amazon.com website for our book. So this suggests that actually, this is an anecdote, not a real scientific experiment, suggests that there needs to be something special or something different if online interactions are to evince a real kind of influence. Now, some people have said, well, maybe if Milano had tweeted about lipstick, then people would have bought lipstick. So maybe it's product specific. Or other people said, well, maybe it doesn't work for Milano. Maybe if you had someone else, like Tim O'Reilly of O'Reilly Media, or some other important figure tweet your book, maybe that would have an effect. And in fact, it's possible through these types of anecdotes and actually broader research, which I won't summarize for you today, to come to a number of conclusions about how we might, if we wished, exploit the online world to change human behavior. So online networks facilitate interactions on a vast scale. 2 million followers get the tweet, although, as we have seen, influence for many processes appears to still depend on interactions among real friends and not mere online connections. So measures of meaningful interaction will be needed if we're going to exploit online ties. And so the question becomes, how can we subset, how can we define which of your online interactions constitute real relationships whereby influence might possibly be exerted? And so it turns out that to use the online world to affect human behavior, a few criteria need to be met. First of all, the interactions must be real or feel real. Okay, so your real friends among your Facebook friends, when they say something, it affects you. You pay attention to it. But when all your other loose, Facebook friends say or do something, it doesn't affect you. So either has to be a real relationship, or I have to be able to cultivate a real sense of authenticity, even if it's a fake sense of authenticity, between you and that other individual. A second thing that must be understood is that something has to be at stake. You can actually have interpersonal influence between strangers online if something's at stake. For example, they're looking for sexual partners, okay? You can find a partner using an online network with a stranger because you both want to have sex. Or if you're looking to transact business, you're trying to sell a product, strangers can find each other, get good matches, and affect each other. Or if you're trying to quit smoking, so you have strangers that sign up for online smoking cessation programs, and they both want to quit, and they can mutually support each other because something is at stake. They wish to quit smoking at the same time. Or people with cancer, as we discussed in the book in the example, people with cancer that want to find out about good treatments, and they want to get advice about what kind of treatments they should use. If I gave you some advice about what you should do, you would probably ignore it. You don't know who I am. But if I have cancer and I look for another patient who also has cancer and I say, can you advise me on what to do? Something's at stake in that situation. Those people can affect each other. And third thing that's important to understand is that many people are obsessed with finding, influential people online. How can we find who's influential? But the thing is we don't just need leaders, we also need followers. We don't just need shepherds, we also need sheep. We need technology that will identify not only who the influential people are, but also who the influenceable people are. How can we identify groups of interconnected individuals such that if we change the mind of one person, he'll have or she will have someone that will copy them and that will follow them? Now, I'm often asked about this set of arguments with respect to the recent events or a year ago events in the Arab Spring. And scientific papers are now beginning to appear that analyze what happened in the Arab Spring with respect to online communications. And I think I can summarize that literature fairly accurately by saying that what was spreading using online media during the Arab Spring was information, okay? So online networks are very effective for disseminating information. Let's understand clearly what I'm saying here. I am not saying that you cannot gather information by even relatively anonymous Facebook friends of yours. Your Facebook feed has all these little pieces of news that are algorithmically presented to you. You might click on links, you vaguely know this person, but still there's a link there, you click on it, you learn something, you get some information. That's different than that person affecting your behavior. And so the argument with respect to the Arab Spring is that what was spreading from person to person was information about, for example, where protests were located, not revolutionary zeal. Right? This anonymous person or relatively anonymous, tenuous Facebook link of yours that says, to the barricades, isn't going to make you a revolutionary. But if you're already inclined to be a revolutionary, you can acquire information, for example, about where to go. So there's a big important difference between the diffusion of information, which is in fact facilitated by these technologies, and the diffusion of influence, which is facilitated by these technologies, but only for individuals for whom either there's a real relationship or something is at stake. Here's an example of the online quit network that I mentioned. This is smoking cessation. This was a paper published a few years ago by Nathan Cobb. He mapped a network of several thousand, 7,600 people in an online smoking cessation network. And the red dots are smokers. The blue dots are people who've successfully quit. The green lines are close ties, and the purple lines are looser ties. And through visualization and mathematical analysis of this network, you can see that the smokers and non-smokers cluster in this online network, just like the face-to-face network we saw last time in the Framingham Heart study. And that, in fact, the smokers are recruited progressively at the margins to join the non-smokers. There's a kind of spread of smoking cessation as people are able to quit and support each other. So this study suggests that certain kinds and amounts of online interactions are more important or more conducive to quitting. Using the same Facebook data set I mentioned earlier, where we looked at the spread of movie tastes, we also were wondering, well, maybe we could replicate some of our other findings on face-to-face networks. Remember last time I told you about happiness, and what we did in this situation, this was before there was ease in using natural language processing, which would have allowed us to process the text on people's Facebook pages and make some judgments about how happy or sad they were. Instead of doing text processing, what we did is we looked at people's Facebook photographs. And what we found is that some people had kind of frowny faces on their profile pictures. I've since changed my profile picture. And some, this is James Fowler, had very happy Facebook photographs. And so we painstakingly coded these photographs for whether people were smiling, and the yellow dots are smiley people, and the blue dots are frowny people on this online network. And once again, we find clusters of frowners and non-frowners within the network. And we found that the non-frowners, the people with smiling images, had 20% more friends than the people with sort of non-frowny images, and also were more central within the network. So we were able, again, in some kind of loose way, to replicate the online interactions. And this, I think, this image is just for, is a loose network. As you can see, it has only real friends. It doesn't have any old Facebook friend shown in the ties. Now, this work with emotions and also with altruism that I showed you the last time, which are so fundamental, got us to thinking about the evolutionary basis of networks themselves. To the extent that networks seem to be related to these fundamental properties of human emotional experience and altruistic interaction, to what extent might networks be partially genetically encoded? What's the evolutionary basis and origin of human social networks? Now, human social networks, whenever they have been mapped, always look strikingly similar. They always look like the images that I've been showing you so far. But they never look like this. They never look like a regular lattice, like a sodium chloride crystal. Why not? I mean, why didn't we as a species evolve to make networks that had this type of structure? Why do we instead make networks that have this other type of structure, which seems to be found again and again whenever networks are studied mathematically or otherwise? The striking patterns of human social networks, their ubiquity and their apparent purpose, beg the question of whether we evolved to have networks and to have particular kind of networks in the first place. So now the questions become, why do we form networks, and why do they have the structure that they do? And to understand this, we need to dissect network structure a little bit first. So first of all, notice that in this type of a network, every position is isomorphic to every other position. Every individual has 8 connections. Every one of their connections has 8 connections. And if you took this surface and wrapped it around the surface of a sphere, or more properly in 3 dimensions around the surface of a torus, a donut, every position would be equally distant from the edge as every other position. But of course, that's not at all what we found. This is what natural networks look like. This is, again, a college student friendship network. Every dot's a student, every line represents a close friendship. And as you can see in this image, different nodes within the network have a different position, a different location. So for example, node B has 4 connections. That's known as the degree of a node. Node B has 4 connections. And node D has 6 friends, has 6 connections. And if you talk to nodes B and D, they would know this about themselves. So if I asked you guys, you would know. I've got 6 friends. I've got 4 friends. I've got 2 friends. I've got no friends. People know how many friends they have. But now look at nodes C and D. C and D both have 6 connections. But actually, that might be the limit of their understanding of their position in social space. But we now, with this bird's eye view, can see that nodes C and D actually occupy very different structural locations within the network. And that C is more central than D. And I can cultivate this intuition in you by asking you, who would you rather be if a deadly germ was spreading through the network? C or D? D. You have the intuition, it's better to be D. D is more peripheral in the network. D is going to be less likely to get whatever's spreading, and he's going to be less likely to get it soon in the course of an epidemic. Now let me ask you, who would you rather be if a juicy piece of gossip were spreading through the network? C. You have the impression that this person is going to get it faster. And formally, mathematically, one of the ways you can distinguish between the two is that the mean path length between D and every other node is longer than the mean path length between C and every other node. So C is going to be getting things that spread more quickly. Finally, look at nodes A and B. A and B both have 4 connections, but there's a difference between the two. And the difference is something known as the transitivity, or triadic closure. The friend of A's is back again a friend of A's. But here, the friend of a friend of B's is not a friend of B's. So if I asked you, if you were a prehistoric human and your task was to go out and kill a mastodon, who would you rather be, A or B? A, right, that's good intuition. So all your friends are accustomed, they're a tight-knit group, they're accustomed to working together, you're going to go out and you're going to work together, you're going to kill the damn thing. Now, what if I asked you, your task is not to kill the mastodon, but to find the mastodon? You would rather be B. Because in the case of A, your friend's friend is your friend. Do you know where the mastodon is? No. Do you know where the mastodon is? It just comes right back to you. There's a redundancy in the information. It kind of bounces around in this little click. Whereas in B's case, B's friends of friends reach further away in the system and can bring information or germs back more easily to node B. And so we did, and people often ask me, I'm often asked this question, well, what's the best place to be in a network? And I give the very unsatisfying answer of it depends. Because it depends on so many things. It depends on what you're trying to achieve. It depends on what's spreading through the network. You know, if Ebola is spreading through the network, it's better to be D. If valuable information about resources is spreading through the network, it's better to be C. If your tasks require a high degree of group cohesion, it's better to be A, et cetera, et cetera. So there is no one best location to be in a network. It depends on the circumstances. So we did a simple twin study design to try to get a handle on the extent to which these three traits were heritable. And a twin study design, very briefly, and there's a long literature on this and the strengths and limitations of twin studies. I'm not going to go into that today. Just accept that they're not a bad way to understand the world. It takes advantage of the following intuition. Imagine we had monozygotic twins, so identical twins, and we mapped the network of the two twins, A and B. And we saw that their networks were very similar, here rendered visually. For example, this twin has 1, 2, 3, 4, 5, 6 connections, and this one has, I don't know, the same number of connections or similar number, and they're interconnected in the same way. But here, when you had same-sex dizygotic twins, A and B, you see that their networks are very different. This person has higher degree than this person has higher transitivity than this person. The networks, when you map the networks of dizygotic twins, let's say you found that on average in large samples, the networks of dizygotic twins were more dissimilar than the networks of monozygotic twins were. That would be some very suggestive evidence that there was a partially heritable basis for the structure of networks that we all, you two, make. And in fact, when we did this, what we were able to show is just that. So what we found was that 46% of the variation, so on the y-axis is the percent of the variance explained, or the heritability, 46% of the variation in how many friends you had, or the degree, can be explained by your genes. And this is not very surprising at all. All of you are probably familiar with the idea that some people are born shy and some people are born gregarious. People vary in their interest in having friends. And it's not a shocker to discover that some of that variation might be inborn. We might be born with that variation. But we also found that some of these higher order structures, quantities within networks also were heritable. For example, 47% of the variation in your transitivity was heritable. Now, this is one of the most surprising results that we've had in my lab in the last 5 years. What I just told you is that if you have Tom, Dick, and Harry in a room, whether Dick is friends with Harry depends not just on Dick's genes or on Harry's genes, but on Tom's genes. Whether Dick is friends with Harry depends on the genes of some other person, this guy over here, Tom. How can that be? Well, we think the reason is that people vary in their tendency to introduce their friends to each other. Some of you guys knit the networks around you together and increase the transitivity around you, and others of you in sort of worlds collide theory keep your various lives separate. You know, don't introduce the lacrosse team friends to the, chemistry pre-med group. You just sort of keep them separate for everyone's sake. And then last, even 29% of the centrality in how central you were also could be explained by your genes. We have some ideas about why that is, and we can talk about that some other time. So, where you are in this vast fabric of humanity depends in part on your genes. The fundamental reality of our desire for connection and our susceptibility to influence, it turns out, has always been with us. And this is very important to sort out, I think, because if genes are associated both with network topology and with behavioral outcomes, interpersonal effects might depend on both. And in fact, we might be fundamentally misunderstanding a lot of phenomena. So other people have looked at the way in which genes, for example, in the dopamine or serotonin pathway, affect various human behaviors. So we have a lot of evidence now that various kinds of neuroendocrine pathways and so forth, which are partially genetically determined, are responsible for a diverse set of human behaviors like obesity, smoking, happiness, voting, and altruism. In last lecture, I told you that social networks could play a role in these behaviors, and I showed you evidence on obesity, smoking, happiness, and altruism. And today, I just showed you that genes may play a role in social networks. What this means is that, in fact, we may be misunderstanding part of the effect that genes have on behaviors, because they work not just by what they change inside your body, but what they change outside your body. So what may be happening is not just that the genes affect your neurobiological response to the world, but also your sociological response to the world. And so if you ignore the extent to which your genes, for example, maybe genes make you want to have more innovative or risk-taking friends, or happier friends. Maybe you're predisposed to picking happier friends. And maybe having happier friends makes you happier. So maybe if I think that the way the genes are making you happier is by what they do inside your mind, I'm actually mistakenly concluding that, whereas in fact they're having some effect via this backdoor path. So this in turn raises still further questions about why networks might be genetically encoded. And we're coming to think that part of this must be because human social networks enhance our fitness. And more recent work of ours has shown, in fact, that there are correlated genotypes in friendship networks. That is, there are genetic consequences as well as genetic antecedents to the friends we pick. It turns out we're finding that when you go out and pick your friends, you pick friends who have not only particular genetic profiles, but genetic profiles that seem to match your own genetic profile in ways that we think are very profound and have significant implications, not only for evolutionary biology, but also for understanding of human behavior. There are deep reasons we have friends, it turns out, and there are deep reasons that we are homophilous. So one of the things that I've been trying to do in our lab in the last few years is to problematize seemingly very obvious phenomena. So for example, all of you probably take it for granted that we have friends, but ask yourself this: why do we have friends? I mean, not other species don't do this. Even other social species don't have long-standing, non-reproductive unions to specific individuals the way we do in the way that we have friends. Elephants do to some extent, dolphins do, certain primates do, but not all species do, certainly not all mammalia. So we're unusual as a species in that regard, plus we're unusual in another regard, which is that not only do we have friends, but we prefer the company of people we resemble. And this is a widely understood fact of life. But why? I mean, this needn't have been the case. We could have been a species that was not homophilous, but heterophilous. It's not possible to construct an argument for why it would be to my advantage, like Master Blaster and Mad Max 2. Raise your hands if you've seen that movie. Thank you. So I'm telling myself. So, it might have been to my advantage if, one guy's strong and one guy's smart. Those might be good unions rather than having, smart people hang out with smart people and strong people hang out with strong people, for example. So maybe heterophilous unions might have been more socially efficient than homophilous unions, yet that's not what we see. We see widespread homophily in social systems everywhere. Why is that? Is an important question. So to begin to study some of these questions, what we thought we would want to do in an ideal world is be able to build a time machine and travel back 10,000 years to the Pleistocene and study how human beings constructed networks 10,000 years ago when we lived as we did, as our ancestors did. Now, obviously, that's not possible, but we came up with what we think is a plausible proxy for that, which was to study the Hadza hunter-gatherers of Tanzania. Now, the Hadza are one of the last remaining hunter-gatherer populations on the planet. They hunt and they gather for their food. They're a pre-agricultural society. They're a natural reproduction society. They have no forms of birth control. They have very limited material possessions. They sleep under the stars. They don't build fixed dwellings. And they can carry all their possessions in just one little, over their shoulder. And they live, as near as we can tell, the way we did tens of thousands of years ago. So along with Corinne Apicella, a postdoc of mine, and James Fowler and Frank Marlowe, one of the world's authorities on the Hadza, we decided we were going to map the social networks of the Hadza. And there are only about 1,000 of them left. Only about 600 of them live in the traditional way. Only about 400 adults. And so these are 17 Hadza camps that are located around Lake Eyasi in Tanzania. And Corinne got into a Range Rover and went there and drove 3,000 square kilometers over the course of the whole summer. And she took with her something we had made, which was a kind of photographic census of the Hadza, otherwise known as our Hadza Facebook. And so we made these big posters of the Hadza. Every adult had a photograph, and we arrayed them in random order, and we had replicates of these posters that were painstakingly taken to the field. And Corinne, every Hadza, she had previously worked with a Hadza, every Hadza adult she found, she asked them to identify who their friends were. Now, the customary way to doing that in our society, if you don't have access to Facebook and online media, is to ask people two key questions known as name generators, as discussed in the book. And those are who do you spend free time with and who do you discuss important matters with? Those are the key questions that are usually seen as ways to identify who your real friends are. And it would work for most of you. If I asked you, who do you spend your free time with, and who do you discuss important matters with, that would probably reliably identify your friends. And on average, it would produce about 4, 5, or 6 friends for each of you. Some of you would have nobody, about 5 or 10% of you, maybe not in this population, but the average American. Some of you would have 8 or 9, about 5 or 10%, but most of you would peak around 4 or 5. But we didn't want to use these questions with the Hadza because, the Hadza have a lot of free time and they hang out together in their camps, and we just didn't think that would be a very accurate capture of real relationships among the Hadza. So we had to come up with a couple of other examples of how to discern real relationships. And one example is what we call the camping network. We asked the Hadza, with whom would you like to live in after this camp? And here we had restricted them to same-sex networks because we didn't want the Hadza to identify targets of sexual opportunity in their next camp. So we said, same sex, who would you like to live in the next camp? You could pick people that are in your current camp or any one Hadza you know, and choose up to 10 individuals. And the other thing we do is we took thousands of these little honey sticks that we got from Costco into the field. This was actually a huge logistical challenge, obtaining and transporting these honey sticks. Honey is the favorite food of the Hadza. They do have honey indigenously. It's very difficult for them to get, and it's fascinating if you want to read about honey acquisition among the Hadza, how they do it. But we took these sticks and we gave every Hadza respondent 3 honey sticks, and we said, you cannot keep these for yourselves. To whom would you give them as a gift, anonymously? And we used this as a way to map the gift network of friendship within the Hadza. And when we did that, we got a network that looked like this. In fact, the Hadza network look identical to the modern networks that we make. Despite the fact that we have, since the Hadza, invented agriculture, invented cities, invented telephony, invented the internet, done all of these things, the networks we make are the same structurally as the Hadza. And they're the same in every kind of way that we could measure. They had the same degree distribution, the same average number of friends, and the same distribution in the number of friends across individuals. They evinced the same amount of homophily that we did. The Hadza are homophilous just like we are. They showed the same decay with geographic distance, a declining probability in having a friendship with someone the further and further away they live for you. So like if you're in Foho, you're unlikely to have a friend at Mather, for example. That same extent of transitivity. So that is to say, the same extent to which if you guys are both my friends, there's a 0.4 probability that the two of you will be friends in this population. So hi, I can introduce you. And the Hadza is the same as we are. And if you actually look at a group of your friends, make a list of your friends, and then ask them or ask yourself, how often are each of those pairs of individuals friends, do that as an exercise on your own, you'll see that it'll not be 100% or 0%, it'll be about 40%. They also evince degree assortativity, which is very interesting. It means that popular people befriend popular people. There's homophily on degree in our networks, and Hadza do that just like we do. And finally, they evince similar extent of reciprocity. If I say you are my friend, you're very likely to reciprocate that nomination and say I am your friend. And these features, this degree assortativity, the homophily, the reciprocity, for reasons we argue in the paper that was assigned for today, actually have very fundamental implications for human social existence. Actually, these structural attributes of networks confer certain advantages on us as groups. And actually, I think that it turns out, I don't have time to discuss this, but it turns out that, this is very interesting, this blows my mind. Okay, here's the idea, I'm gonna do it very quickly. So if I took you guys and I said, okay, I have you 100 kids, and I'm gonna give each of you 5 ties on average, so there are 500 ties. And I could organize you in one way, like I could make a regular lattice arrangement of you, 100 kids, 500 ties. Or I could organize you as a random network. So some of you would have no ties, some 1, some 2, some 3, but I'd use up all 500 ties. Or I could organize you in yet another way, for instance, having this property of degree assortativity. There are different ways I could organize you guys, and those ways differ in the way in which the group of you would become susceptible to an epidemic. One way of all those ways renders the group relatively more resistant to pathogens, and that way is to have degree assortativity. If you make popular people friends with popular people and unpopular friends with unpopular people, that arrangement of the ties makes the group as a whole more resistant to inroads of epidemic disease. So it cannot be, in my judgment, a coincidence that we assemble ourselves into that kind of a network. Even above and beyond your individual attributes, your immune systems, your individual traits, above and beyond that, we arrange ourselves in a fashion that gives the group properties that are different than the properties of individuals. And I actually think, in a very real sense, The spread of germs is the price we pay for the spread of information. We assemble ourselves into networks. We come into contact with others so as to benefit from each other. So I can learn from you. You put your hand in the fire, and when you do that, you teach me something, but I pay none of the cost. You put your hand in the fire. But to acquire that information, I have to connect myself to you, which exposes me to risk that you'll infect me, that you'll be violent to me, that you'll do other things. So across evolutionary time, we believe there's been a kind of balancing of the costs and benefits of social interaction and of particular kinds of social interaction, which culminate in us today having networks with particular topologies. And in fact, I think social networks are very deeply embedded in our evolutionary heritage. Now, while we were with the Hadza, we also revisited this issue of cooperation. We had them play a public goods game, like the last time I showed you. Dot size here is proportional to how altruistic the individuals are. Bigger yellow dots are the bigger donators, small red dots are the defectors, and we find clusters of cooperators and non-cooperators within the Hadza networks. The networks are constituted in such a fashion as to magnify the benefits of cooperation that individuals might evince. And in fact, we're not only affected, as I showed you last time, by what's flowing through the network, the actual structure of the network can matter as well. And this is another important idea that I want to convey to you about social networks. So far we've been highlighting the ways in which spreading processes within networks, whether germs or ideas or behaviors or practices, how they might flow through networks and how your location within a network might depend on what's spreading. But there's another broad way you're affected by networks, and that's not just contagion, but also connection. And so here's an example of this. This is some work done by a sociologist by the name of Brian Utsi at the Kellogg School at Northwestern. Brian became, for reasons that are completely obscure to me, interested in the success or failure of Broadway musicals. And what he did is he assembled a data set of 326 Broadway musical production companies, the director, the producer, the actors, and the musicians, and so forth. And he mapped the networks of these production companies. So for example, and he measured a quantity known as density, which is very similar to transitivity. So here imagine a little cartoon of a network of 6 people. This individual is connected to 5 people. 5 times 4 divided by 2 possible connections exist amongst these 5 people. 10 connections, possible connections exist. None of them are present. There's 0% density in this system. Here, 4 of the ties are present, 40% density. Here, all 10 of the ties are present, 100% density. And then he plotted the density on the x-axis versus the success rate of these Broadway musicals, and he measured the success rate by the amount of money they made and the fraction of positive reviews they had. And he found that if nobody knew each other from before, the show was a flop. And if everybody knew each other from before, the show was a flop. Optimal performance by this group of creative individuals was achieved in intermediate density, when some people knew each other from before and some people did not know each other from before. So if you want to go and get a mastodon, you need some people who've worked together before who can kill it, and some people who haven't worked together before, don't know each other, who can find it. And this type of intermediate transitivity is optimal in the case of this type of performance. This is different than the Behrman study, which you read for today, which showed that a young girl's probability of thinking of killing herself rises or declines monotonically with density. So young girls who have friends who aren't friends with each other are always more likely to want to kill themselves than young girls who have friends who are friends with each other, for reasons that are discussed in the reading for today. So we've begun to use some of these ideas about how the structures of network might affect you to explore broader phenomena that are of relevance in contemporary society. Just to digress a bit, in some work we've done since the book was published, what we've begun to do is map networks of interactions amongst physicians. And we've done this by taking advantage of millions of claims. Every time patients go to doctors, insurance companies get bills for that care, and it turns out we can take those bills in ingenious ways and map networks of doctors. So here are 4 doctors, 1, 2, 3, 4, and here's some patients labeled A through K, and Doctor 1 takes care of patients A, B, C, D, and E. Doctor 2 sees patients B, D, F, and G, and so forth. And we can take this so-called bipartite network and project it onto a unipartite plane and create a network of physicians where the ties represent how many patients they have in common. So doctors 1 and 2 share 2 patients in common, 2 and 4 share 1 patient in common, 1 and 3 have no patients in common, and so forth. And we've done this to map the networks of the whole country. And we've begun to study how these structural features of the networks in which doctors are embedded affect the kind of care that they deliver. And we found some pretty amazing things. So this is a network map of doctors. Every dot's a doctor. Every line represents that they share some number of patients in common. And what we've done here is this is doctors caring for patients at one hospital in New York State. There are about 1,000 doctors in this network. This hospital takes care of about 300,000 patient days per year. We color the dots red if they're a primary care physician, otherwise they're a specialist. And if you look at this network, you can see that the specialists occupy the central position in this network structurally. And patients that are cared for in this hospital who die in the last 2 years of life consume $104,000 worth of care and spend 48 days on average in the hospital. On the other hand, hospitals in which the doctors are structurally arrayed in a different fashion, here the generalists in red are located in the center, use half as much money, $46,000, and spend half as many days in the hospital, 25 days. So the nature of the care that a group of doctors is able to deliver to patients depends on the structural arrangement of the doctors above and beyond who the doctors are. Where are the doctors in the network affects the kind of care the group is able to evince. Similar to the idea I introduced at the beginning of last lecture when we talked about the bucket brigade and the telephone tree, same human beings arrange them differently gives the group different properties. We've also gone on to look at the prescribing behavior of these doctors in a different study using different data. This is a network of doctors in Raleigh-Durham, North Carolina. We've done it for the whole country. 650 doctors. We make the dot size proportional to how much of this anti-diabetic medication called Januvia they prescribe. Bigger dots are bigger prescribers. We color the dots orange if they prescribe, otherwise yellow. And the color of the lines connecting the doctors represents how many patients they share in common. And if you look at this network, you can once again see clusters of Januvia prescribers and non-prescribers within the network, and amazingly, these clusters spread to 3 degrees of separation. Whether or not doctors prescribe particular medications depends in part on whether other doctors to whom they are connected at some distance within the network also prescribe the medication. And we've even begun to look at networks of hospitals. This shows 5,000 hospitals mapped in the United States. The lines represent transfers between the hospitals. This type of analysis can be really useful in responding to or understanding a bioterror attack or an outbreak of nosocomial infections. If you're trying to understand where should you intervene or cut ties between hospitals to contain an attack of one kind or another. So, social networks, in my judgment, and I'll close with this set of arguments, in my judgment, offer a new way to understand human behavior and human society. Now, one classic way of understanding collective human behavior is to examine the choices and actions of individuals. For example, we can see markets, elections, or riots as the mere byproducts of individuals' decisions to buy and sell goods, cast a ballot, or express anger. And the classic example of this approach, which is known as methodological individualism, is provided by Adam Smith's conception of markets as the simple sum of individuals' willingness to supply or demand a good. So Smith makes the famous argument that each individual, as if guided by as each individual acting in his own best interests, as if guided by an invisible hand, comes to create this collective existence of markets. So we understand markets by studying individuals, is Smith's argument. And this was sort of a way that was proposed in the 18th century of understanding collective phenomena like markets, elections, riots, and so forth. Now, in the 19th century, another classic way of understanding collective human behavior dispensed with individuals and focuses exclusively on groups delineated by, say, class or race, or class or race, each of which was seen to have a kind of collective identity that caused people in these groups to act in concert. And some scholars in this tradition, for example, famously Karl Marx, believe that groups have their own consciousness, imbuing them with an indivisible personality that cannot be deduced or understood by studying the actions of its members. Now, others have also focused on the primacy of group culture. For example, sociologist Emil Durkheim, the first lecture when we talked about this suicide, remember he argued that the relatively constant rates of suicide in different religious groups across time and space could not be explained by the actions of any individuals, since the groups had an enduring reality that long outlasted the lives of their members. How was it, he wondered, that people came and went, but the suicide rate in French Protestants stayed the same? There was something about being a French Protestant that had nothing to do with you as an individual. And if you were a French Protestant, you were obligated in some way to adopt this probability of suicide. Even this seemingly deeply personal behavior, whether you kill yourself or not, was guided in part by your participation in this whole that was greater than yourself. So Durkheim and Marx are in this type of tradition, and this tradition is known as methodological holism. And this approach sees social phenomena as having a totality that is distinct from individuals and then cannot be understood merely by studying individuals. Now, in the 20th century, social scientists started expanding on this to some extent, and they began to focus on how membership of individuals in groups via the sharing of particular traits or attributes could help explain their behavior and collective phenomena. So we've had 100 years or 50 years of regression models in which we've said, if I want to predict what you do, I need to know your race, your age, your income, your education, where you're located, a whole bunch of stuff about you. And once I know all that stuff, I can fit it in and make some assumptions of linearity and all kinds of other assumptions which are typically ignored, and get an equation. And when I get that equation, I can make a prediction about what you're likely to do. And I can understand your behavior as a function of your several membership in different classes of individuals, as shown by this kind of schematic. But these two traditions, in my judgment, individualism and holism, shed some light on the human condition, but they miss something essential. In contrast to both individual and holism, the science of social networks offers an entirely new way of understanding human society because it is about both individuals and groups. And indeed, it's about how the former become the latter. Interconnections between people give rise to phenomena such as economic productivity or pathogen resistance or cooperation that are not present in individuals and not reducible to the solitary desires or actions of individuals. Hence, methodological individualism seeks explanations for social phenomena, such as social class, markets, power, institutions, and so forth, by saying that they must be formulated as or reducible to the characteristics or actions of individuals. Whereas methodological holism sees each social entity, group, institution, or network as having a totality that is distinct from and that cannot be understood by merely studying its individual component elements. And in fact, as far as I'm concerned, the study of social networks is, in fact, part of a much broader, what I call, assembly project in modern science. For the last 400 years, swept by a reductionistic fervor and by considerable success, scientists have been purposefully examining ever smaller bits of nature in order to understand the whole. We've disassembled life into organs, then cells, then molecules, then genes. We've disassembled matter into atoms, then nuclei, then subatomic particles. We've invented everything from microscopes to supercolliders. But across many disciplines, scientists are now trying to put the parts back together again, whether macromolecules into cells, neurons into brains, species into ecosystems, nutrients into foods, or people into networks. Scientists are turning their attention to how and why the parts fit together and to the rules that govern interconnection and coherence. And understanding the structure and function of social networks and the phenomenon of emergence in social networks is thus a part of this, in my judgment, awesome scientific movement. See you next time.